another 50 years. Our second speaker is Woja Choi,
Yep.
and he's from Seoul National University, and he's going to discuss well-to-wheel greenhouse gas emissions of current and future passenger vehicles in a South Korean case study.
Yep.
All yours.
Thank you for introducing me. Hello, my name is Woja Choi, and I am postdoc of Seoul National University in South Korea. Today I'm going to talk about the well-to-wheel greenhouse gas emissions of current and future passenger vehicle pathways in South Korea. Several transportation fuels and powertrains are being developed in these days. For example, hybrid electric vehicles fueled by gasoline, battery electric vehicles fueled by electricity, and fuel cell electric vehicles fueled by hydrogen. Along with this diversification, a question has come up. Then what is the best option for the environment? What is the lowest GHG emitting vehicles? To answer this question right, the comparison should be performed in the life cycle point of view. Because as you know, battery electric vehicles and fuel cell electric vehicles don't emit any GHG from their tailpipe, but do emit GHG in the process of producing fuel of their vehicles. Thus far, well-to-wheel analysis have been mainly utilized as the method to compare these vehicles. Well-to-wheel analysis evaluates the GHG emission generated from every process in the life cycle, from the well of the fuel to the fuel of the vehicle. One interesting point of the well-to-wheel analysis is that the result of the well-to-wheel analysis can be differed according to the target region and the corresponding situations. For example, this slide shows the well-to-wheel greenhouse gas emissions of the battery electric vehicles in the United States. And as shown in the slide, even in the United States, the result can be differed according to the state, like this, because of the difference in the electricity power generation mix. Thus, well-to-wheel analysis should be performed for the specific target location and the considering the corresponding situations. This presentation conducts a study well-to-wheel analysis for the case of South Korea. South Korea has two main characteristics in the well-to-wheel analysis point of view. The first characteristic is that the South Korea barely produces primary energy sources and heavily dependent on the import of fuel from overseas. Overall, 94% of primary energy sources is imported from overseas. And because of to reduce the economic and political risk, South Korea imports various fuel from the various countries, like this. And on top of that, because of the geopolitical reasons, South Korea is an island-like country, so it should import all of the fuel by maritime transportation. And this fact makes the well-to-wheel analysis more complicated. The second characteristic is that the government and industry of South Korea have been very, very interested in promoting alternative vehicles. South Korea has 12th largest economy in the world in 2017, which is centered on the manufacturing and technologies. The size of car industry is also large because South Korea has Hyundai Motors Group, which is the fifth largest automobile manufacturing company in 2017. So the government and industry have strongly pursued developing and supplying the alternative vehicles like this. And this is the hybrid electric vehicles and BV and FCV. And according to the government's target, about 20% of total new passenger vehicle sales will be taken by the alternative vehicles in 2020. This is the BV and this is the FCV. And as you can see in the slide, it will be increased exponentially according to the government target. And along with this increase, electricity and hydrogen should be produced more. Thus, the production mix of the electricity and hydrogen would be changed in the future, and that would change the result of the well-to-wheel analysis also. So in this presentation, these two main characteristics are considered, and the analysis was performed. Next, I will introduce the scope and methodology of the present study. To conduct the well-to-wheel analysis for the case of South Korea, we utilized the GRIP program developed by the US Argonne National Laboratory. We modified and expanded the model and replaced the majority of the data in the model to the Korean-specific data. The scope of study is like this. It covers the all passenger vehicle pathway in South Korea. To conduct the well-to-wheel analysis on these pathways, the entire life cycle of the transportation fuel should be defined and analyzed. And this slide shows the entire life cycle of the transportation fuel used in South Korea. It is divided into two parts. First part is life cycle of the primary energy sources, and second part is life cycle of the secondary energy sources. First, it should be analyzed. First, we should analyze on the primary energy sources, because some primary energy sources is used in the producing secondary energy sources, electricity and hydrogen. To conduct the well-to-wheel analysis, each process should be analyzed, and the GHG emission generated from each process should be calculated. But today, I'm not going to go through the details of this analysis, but I just want to mention that the final result of well-to-wheel analysis is based on the analyzing these all processes. Yeah. Next, I will show you the result of the result for the current state first. This slide shows the well-to-wheel greenhouse gas emissions of all passenger vehicle models sold in 2017 in South Korea. In the graph, y-axis indicates the well-to-wheel greenhouse gas emissions when a vehicle traveled 1 kilometer. And x-axis shows the curve rate to compare the various vehicle type in the same curve rate. And if you see the result, the GHG decreases in order of ICB gasoline, ICB diesel, LPG, hybrid electric vehicle, plug-in hybrid, and battery electric vehicles, and fuel cell electric vehicles. And the comparison become more clearer in this slide. This slide shows the average GHG emissions of each vehicle type, calculated by weight averaging the previous result with the sales mix of each vehicle model. And they shows the similar trends. As you can see, the GHG emission decreases in order of ICV, gasoline, diesel, LPG, HEV, PHEV, BEV, and FCV. However, it should be noted that the result of BEV and FCV is significantly affected by the production mix of the fuel. If you see this part, even though the average BEV emits lower GHG emission than ICV, HEV, and PHEV, if you run BEV fueled by electricity produced from the coal power plant here, it emits larger GHG than HEV in South Korea. And also for the case of the FCV here, when we use the byproduct hydrogen, it emits very low emissions. But if we use the hydrogen produced from the SMR, natural gas steam methane reforming, it emits similar GHG compared to the HEV. And moreover, if we use the electrolysis, it emits very high emissions because currently electrolysis is conducted by the grid electricity rather than renewable sources. Next, I will present about the result of future prediction. For the future prediction, three parameters are considered. The first one is the changes in the generation mix. Currently, in South Korea, power generation is conducted by this mix. Coal takes 40%, nuclear takes 30%, and natural gas takes 20%, and only 2% is conducted by the renewable sources, wind, water, solar. In South Korea, the government has announced a national electricity supply plan in every 2 years. And this slide shows the prediction of South Korea power generation according to the 7th electricity supply plan. As you can see, the total amount of the power generation is increased, somewhat increased like this. But the share of each technology is not that different in the future. This slide shows the changes in the power generation mix. If you see this graph, there is some small increase in nuclear and small increase in renewable and small decrease in natural gas. We set this case as the reference case in this presentation. And in 2017, the current administration announced the 8th national plan. The most important characteristic of the plan is decreasing nuclear power. It is a political issue, but the current administration intentionally will decrease the nuclear power, as shown in this table. The vacancy will be filled with the renewable powers, and we set this case as the denuclear power case. The second parameter to be considered in the future prediction is the changes in the production mix of the hydrogen. South Korean government have been very, very interested in promoting fuel cell electric vehicles. The South Korean government, last year, South Korean government selected hydrogen economy as one of 3 major investment sectors with AI and blockchain. And this year, the government announced the hydrogen economy roadmap to become a leader in the hydrogen industry. The government thought that it could be our next technology and our next industry to develop our economy more. As you can see in here, the government target to increase the FCV exponentially, and along with that, the production of the hydrogen should be increased more, and also the gas station will be increased like this. Currently, the hydrogen is produced mainly by the byproduct from the refinery. Yeah, but it is the byproduct hydrogen, so it is basically byproduct hydrogen. So the amount of byproduct hydrogen is limited. So in the future, it will have a different production mix, and natural gas will take more portion, and some electrolysis and some byproduct. We set according to the government plan, we set the reference case like this. And we set two more cases for comparison. The first one is reference with the WWS. It means the electrolysis will be performed by the renewable sources. And the second one is byproduct hydrogen gas case, which shows more byproduct hydrogen in this case. The third parameter to be considered in the future prediction is the changes in fuel economies. We utilize the autonomy program developed by the US Argonne National Laboratory, and I will just skip this part. Yeah, and the most important thing is the ICB gasoline is expected to have large increase in fuel economy, considering the relatively low fuel economy compared to theoretical values currently. And the most of improvement will be achieved through the turbocharging and electrification. And later the BEV, which is quite efficient already, has small improvement potential like this. This is for the gasoline ICB, and this is for the BEV. We set 3 cases. And by considering 3 parameters, this slide shows the result of the well-to-wheel analysis. The most important thing is the absolute gap in the well-to-wheel greenhouse gas emission among powertrain technologies reduced as time goes because of the fuel economy improvement in the ICB. And it should be noted that the well-to-wheel greenhouse gas emission of the FCB increases because of the because in the future, natural gas and electrolysis will be used more for the hydrogen production. This slide shows the last result. Overall, the trend remains similar while the gap is reduced. And if you see the hydrogen with the renewable case, it can reduce the GHG emission a lot. So, and the byproduct hydrogen case, it can reduce the GHG emissions more. So it is important to maintain clean hydrogen production mix. Yeah, this is all I prepared. And thank you for your attention.